Hello, ladies and gentlemen. Welcome to Math 3. This is the very first lesson of Unit 1, Day 1. We're going to do a review about lines and angles, more specifically, what happens when the lines are parallel and what becomes of the angles when that happens. So we're going to delve right into that. First, let's define what parallel lines are. We know what parallel lines are by looking at them, but there's some notation that you might not be aware of. First of all, we tend to make arrows on the lines, not just the ends of the lines, but specifically in the lines. A lot of times they're filled in, but you don't need to fill them in to show that they're parallel, as long as there's arrows pointing in the same direction. So there, we call these coplanar, which means they lie in the same plane. Because you can have lines that don't cross, that don't lie on the same plane, but we're talking specifically lines that are on the same plane or piece of paper, and they never intersect. Their symbolic notation, let's first talk about this segment right here. We would say in this specific picture that line L is parallel to line M. So here's a diagram representing this very same symbol. And this symbol is used a lot in shorthand, especially when you're doing proofs and other things when you don't want to write the word parallel or draw the picture of the lines. Second, we'll talk about vertical angles. This is an important concept. Vertical angles are angles that are across from each other. Okay, they're not going to be touching each other except at the vertex. They're going to be congruent to each other. So angle 1 and angle 3 are considered vertical angles, and angle 2 and angle 4 are considered vertical. So we call these non-adjacent. The reason I say non-adjacent is because they don't share a side. Okay, so we're not talking about angle 3 and 4. We're talking about angle 1 and 3, or 2 and 4. So angle 1 and angle 3, or angle 2 and angle 4. And an important concept is vertical angles are congruent. And pretty much from here on out, I won't ever write the word congruent, and instead I'll use this symbol here, which stands for congruent. So you could say angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And let me do a quick example here, even though it's not on your notes. But if I were to say this was 40 degrees, for example, I could say angle 3 is 40. And because these two angles form a line, they're going to be supplementary, which means they add to 180. So if I subtract 40 from 180, this would be 140, and the opposite angle would be 140. So I can get every angle in that diagram just from one. It's kind of cool. When I have more than one line drawn, or more than two lines drawn rather, if I have two lines, a lot of times they're parallel, but if you just have two lines and you intersect them with another line, that line right there is called a transversal. And it's going to form 8 angles, some of them being interior, some of them being exterior. So the interior ones would be like 5 and 6, 3 and 4. And the exterior ones would be the ones on the outside of the lines. So 1, 2, 7, and 8. These are exterior. So angle 1, angle 2, angle 7, angle 8. And the interior would be angle 3, angle 4, angle 5, angle 6. Now normally we don't just do it in terms of just interior or exterior. we go by specifically what kind of interior exterior angles they are. So getting into that more generally, we first talk about, what is a corresponding angle? And corresponding is just fancy word for saying same position. So if you were to imagine these lines were to come together and you look at angle 4, that's in the bottom left part of this group of angles. So if I go down here, which angle would be in the bottom left of that group of angles? Well, it turns out it's that angle. All right, so corresponding in the same position, they would kind of overlap each other if these lines were to line up. So we'd say angle 4 and angle 8. Can you think of a few other pairs? 1 and 5. You can do 2 and 6. And the last ones would be 3 and 7. Corresponding angles. Alternate interior angles, if you look at this transversal, this is your dividing line. If you look at just the interior angles, 3, 4, 5, and 6, alternate ones would be on opposite sides of the transversals, not next to each other though. Now, those are supplementary, those form a line, but just on opposite sides on both sets of angles, 4 and 6, and you could also do 3 and 5. So they're non-adjacent. So they're on both sets of angles, 4 and 6 and 3 and 5. Alternate exterior follow that same rule except they're on the outside. So 8 and 2, 1 and 7. And the last pair, and there's definitely other pairs of angles that might not have a name that you can still come up with a relationship. But the last pair that has a name is same side interior, and a lot of times we call these consecutive. So they mean the same thing, but basically these two angles would be angles that are non-adjacent, but they're on the same side of the transversal. So like 4 and 5 and 3 and 6. By extension, you could also say angle 1 and angle 8 would be same side exterior angles, and 2 and 7 would also be same side exterior. So let's talk about what happened. Let's identify some angle pairs first. I want you to pause the video and see if you can do these 9 before I give you the answers. All right, hopefully you've had a chance to go through and answer the questions. I'm going to go through each question one by one. 1 and 11, these two angles, if it helps, you can kind of cover the middle up. But angle 1 and 11 are, I would call, alternate exterior. All right, 3 and 5, these two are alternate interior. They're between these two lines. About 4 and 12. 4 and 12, they're in the same position. So we call those corresponding. All right, 7 and 10. These are both on the same side of this line. They're inside these lines. I call them same side interior or consecutive. 2 and 8. But with these two lines, these are on the outsides and they're on opposite sides, so they're alternate exterior. 9 and 1, again, they're on the same position, so we say corresponding. 4 and 10 are between the lines, so they're interior and they're on opposite sides, alternate. 5 and 4 are between these two interior, but on the same side. And finally, 6 and 12 are alternate exterior in relationship to those two lines. So hopefully that makes a little bit of sense just in terminology. I'm going to write a few things on here. Basically, what it boils down to is if I make those lines parallel, then what's going to happen is these angles all will have either one or two options, okay? This angle right here, if I call this like 100 degrees, well, then the corresponding angle is going to be 100 degrees. It's going to be the same measure. Any two angles that form a line, add to 180. So this would be 80 degrees here. And we know vertical angles are congruent. So in this example, I either have 100 or 80. You might see 70 or 110 or 50 and 130, whatever it is, you're only going to see two numbers if these lines are parallel. And so if you look at the relationship, talk about corresponding are in the same position. They're going to be congruent. Alternate interior. So are those. 100 and 100, same thing, or 80 and 80. Alternate exterior. Look at this 100 here. Same as that. Alternate exterior, or the 80s on the outside. They're congruent. In fact, all three of those are congruent, but the only one that isn't, the same side ones, let me write that on here. The same side ones are actually supplementary. They're going to add to 180. So that's kind of the oddball there, but that they come up a lot, so you want to understand that. So just looking through the examples here, we want to get all the angles on there. If we know that angle 3 is 147, we can write that right on there. You can probably list all the other angles that are 147 just by the fact that they're either vertical or corresponding. So I know the measure of angle 8 is going to be 147 because that's vertical. I know 147 is going to be angle 1 because these are corresponding. And angle 6 is going to be 147. The other four angles are going to be supplementary to that. So these four angles will all be the same degree. And to get that degree, you're just going to do 180 minus 147, which is going to get you 33 degrees. So you can write it on the diagram. Always try to make a list if you can. So we got 2, 5, 4, and 7. And of course, I didn't list angle 3, but it was given to you. That's 147 too. So we get all 8 of those angles if we know just one of them. So as far as getting the examples going, solving, let's do that in a separate video. So I'm going to pause this, and the second part of the video will go through the examples, solving for x and finding different angle measures.